So welcome everybody to the ADAS meeting here in Cape Town. We're about to begin our first session following the tutorials we held yesterday. So I'd like to begin by asking the chair of the Programming Organizing Committee, Kathleen Labrie, to say a few words.
All right, so yes, I'm Kathleen Labrie. I'm the chair of the ADAS Programming Organizing Committee, and I really want to welcome you to ADAS 31. I wish I were there with you. Trust me, I wish I were there with you. But it's going to be for another time. Hopefully next year we're back to normal. So I just want to take a few minutes to acknowledge a few people. I want to acknowledge the Program Organizing Committee. We're a nice group of people distributed around the world, all type of fields, all type of organization. I encourage you to go to the adas.org website and go see the list of those fine people there who helped put the program together this year again. About the program, all the themes came from you and from the local organizing committee. The POC did the final grouping of the similar suggestions and the final selection. All the oral presentations, the contributed talks, were selected completely author blind again this year. It worked again very well. Once the votes were tallied, we looked at the representation distribution and adjusted a bit so we could meet our minimum diversity requirements. This is the second year of the ADAS Prize for Outstanding Contribution to Astronomical Software. Our winners this year are Doug Tody, Lindsay Davis, and Frank Valdez for the design and development of the core RF system and science packages. So congratulations. Frank will give a talk on Thursday, I believe, towards the end of the conference. And if you wonder how this came to happen, earlier this year, all the POC requested nominations from the ADAS community, and the POC then voted on those nominations that came from you. And if you hear the little meowing, that's my cat, because that's reality these days. Public service announcement, don't forget to submit your proceedings and go to the website for the instructions. And I have to congratulate SAAO. They did a fantastic job. Special kudos to Carolina and Nikki. And a big thanks to Russ, who got the ball rolling, and then to Oleg, who picked up that ball and just ran with it. And he did run with it. Thank you all. And I want to thank our hosts. So the Inter-University Institute for Data-Intensive Astronomy, and then the Center for Radio Astronomy Techniques and Technology, the NRF and SAAO, and National Research Foundation, and South African Astronomical Observatory. Thank you very much for hosting us. And with that, it's Oleg's show. Go for it, take it over. Thank you. Have a good meeting, everyone.
So it's quite a privilege to open this thing. I do have special feelings about ADAS, because ADAS 2 was my very first conference. And then ADAS 3 was my second conference, and then ADAS 4 was my third conference, and then ADAS 5, and well, you get the pattern. Eventually I discovered other meetings. Not all of them were as good, and I have to say none of them were as strange as this one. You know, this is very weird. This is the first time I'm actually seeing someone live for 2 years almost. And obviously we have no idea how to organize a hybrid meeting, so ask me again in 4 days if it worked or not. Bear with any problems in the meantime. But especially I have to say a big thanks to our international guests for turning up, because if you hadn't turned up, it wouldn't be a real meeting. Even if you didn't turn up for the opening remarks, it's still okay. Now that you have turned up, let's please be careful. We gave you 2 masks in your conference bag, so keep your masks on. COVID is still with us. Keep your mask on unless you're eating, unless you're drinking. ADAS stands for Software and Systems. The SS is for that, not for super spreader, so let's be careful. So about the structure of the program, you will see the schedule is a little bit unusual. As a reward for making it to Cape Town, we wanted to give you the opportunity to get something out of it. So we're going to work hard every morning from early on, but you're free from lunchtime, and we only expect you back here for dinner. So you've got the whole day to explore Cape Town and make the most of it, and please do, especially if you haven't been, because there's so much to offer. Logistics, so we are providing dinner for you, not lunch. So for lunch, you're free to go today. For dinner, you get back here, and dinner is going to be served at 7 upstairs on the ground floor restaurant, the same place you had breakfast. And that's going to be all days except Wednesday, because on Wednesday we have the conference dinner, which is going to be at the aquarium. So on Wednesday, we're going to give you lunch here instead after the morning sessions. And then we meet you at the aquarium. Don't be late, because it should be super special. What else? Toilets are in the back here, behind the stairs. And I think that's pretty much it. Please enjoy the conference. And I would now like to yield the floor to our 2 observatory directors. I think Dr. Rob Adam is going to go first, who is Managing Director of South African Radio Astronomy Observatory. And now I yield the floor to Rob.
Anyway, good for a second time. Good morning, everybody, and thank you, Oleg, for inviting me. And thank you, well, sorry, it's good to see Russ again here in South Africa after such a long time. So it was kind of a welcome surprise for me to see him on the screen there. I'm going to share my screen. Okay, this is the propaganda slide where I explain what SARAO is, the South African Radio Astronomy Observatory. It's a national facility of the National Research Foundation, formerly SKA South Africa, combined with the Hartbeespoort Radio Astronomy Observatory to form SARAO. It's the primary science and engineering interface with the international SKA organization, observatory, and is responsible for South Africa's contribution to the infrastructure and engineering aspects of the SKA radio telescope. Also responsible for development and management of the Karoo Observatory site, design, construction, and operation of the Meerkat radio telescope, and coordination of all radio astronomy initiatives and facilities in South Africa and African partner countries. In other words, the countries that joined us as part of the SKA bid. Geodesy and VLBI activities at the Hartraw facility, the African Very Long Baseline Interferometry Network, guest instruments which have been contributed by international partners, such as the S-band receivers which came from Max Planck, the Breakthrough and Listen equipment, which is allowing commensal observations with respect to SETI, and then also human capital development to ensure successful operation of all facilities within the organization. The proper scientific exploitation of the facilities, where we generally don't. We support radio astronomy at the universities through being a national facility. Obviously, we do have our own radio astronomers, but most of the users of our facility sit outside in the universities. And the commercialization of intellectual property developed within SARAO. On to Meerkat, our main facility. It's currently the most sensitive radio array telescope in the world. 64 13.5 meter dishes, designed by South African scientists and engineers, built with more than 75% local content. It was heavily prototyped, which I think was the reason for it performing so well when it was finally built. Construction budget, 3 billion over 5 years, roughly 3 billion. Key technical specifications were exceeded by a factor of 2 for no additional cost, and I think that was the benefit of doing the engineering and the prototyping right. Delivery milestones on schedule, recognized as a key infrastructure project of the South African government. It's an SKA precursor. In other words, SKA is in several phases. This is effectively phase 0. We're about to begin phase 1 construction. It's an engineering prototype, but also intended to do early science. With Meerkat, we were able to build up science and engineering teams in South Africa, to build Meerkat and SKA and also to use them. Currently, over 200 engineers and scientists employed. The Human Capital Development Program to grow and diversify the science, I mentioned that in the previous slide. Also developing industrial capacity in South Africa to compete for SKA procurement packages. Finally, Meerkat will be incorporated into SKA Mid and make up 30% of its collecting area. Getting on to data, I mean, I guess all of you are familiar with the kind of data architecture which a radio telescope array has, but quantitatively, into the correlator there is pouring 2 terabits per second. That's processed in the Karoo array processor building, so CSP, SDP, some archive, and then out of that goes 20 gigs per second into SANREN, in other words, this is the network that comes down to Cape Town, into the Center for High Performance Computing, into the Meerkat archive, and then it goes to other so-called Tier 2 centers, one of which is IDEA, the Inter-University Data Intensive Institute for Astronomy, which Russ represents. The different phases of this, I've said that Meerkat into the correlator goes 2 terabits per second. The SKA1 mid equivalent of that is 25 times higher data rate, 50 terabits per second. And SKA2, well, that's not really even properly conceptualized or designed yet, but the estimate is up to 5 petabits per second. Into the science processor, 0.7 terabits per second for Meerkat, 20 for SKA1 mid. Into the archive from Meerkat, 20 gigs per second, SKA1 mid upwards of 300. Compute load for Meerkat, 200 teraflops, SKA1 mid probably 30 plus petaflops, significant upscaling. Okay, here I get to my issues that I would really like some thought given to over this meeting. More than ever before, astronomy has become a data-intensive science. The torrents of data coming out of Meerkat are unprecedented. The SKA will take this to an even higher data rate, as I've explained. Our relative inability to process this data timeously is proving to be a bottleneck in taking the science forward. In a previous era, handing over the data cubes to the PIs was sufficient for telescope operations to contribute. Now it isn't, and further refinement is necessary. Probably 10 years ago, when we conceptualized how Meerkat would work, we were living in an era where astronomers, so-called black belt astronomers, were able to cope with the data rates that came off instruments fairly easily. You didn't have to do any hand-holding. But nowadays, although astronomers crave data, they don't always know what to do with it when they get it. There are various mitigating measures for this challenge. For example, IDEA, which I've mentioned, is supposed to help address this challenge with respect to Meerkat, to provide the refinement to the data so that real science can actually be done. And the global network of regional science centers aims to do the same for the SKA. So those are kind of current operational challenges which we're busy with. I mean, we even had a crisis in terms of the archive recently because the data was queuing up and it wasn't being utilized. So we'll have to rethink that and capacitate the PIs more than we're doing at the moment. I'm just going to end off with having said that, this is really the end of my talk. Just to show you a couple of pictures, those of you that haven't seen the Meerkat array, there's 64 antennas. You see in the top right-hand corner the Karoo array processor building and the dish assembly shed. The processor building is probably the biggest Faraday cage in South Africa, so that none of the electronic interference gets out as radio frequency interference into the environment and thereby swamps all the signals we're trying to observe. been on the cover of National Geographic already. The most exciting thing for me, or one of the most exciting things, is it was designed and constructed in South Africa, Meerkat. All of these engineering facilities are South African engineering facilities, largely in the Joburg area. There's one of the dishes being lowered onto the pedestal, and then on the right-hand side you can see a dish, the backing being assembled, and in the dish assembly shed, we could fit 4 dishes into that shed simultaneously. This is a clip from the launch of Meerkat, and one of the take-home messages from that launch was that astronomers were astonished that Meerkat worked straight out of the box. And I think the reason for that was that it was done right from the beginning with a systems engineering approach, so that we looked at the interfaces between the different subsystems, made sure that those articulated and worked properly together. That was our brag picture image at the launch, which is you're probably very familiar with it, but it's a radio image of the center of the Milky Way, our galaxy, 25,000 light years away. And the reason that that's a brag picture is that it's very bright from a radio perspective, and it's a bit like, from an optical perspective, taking a picture right into the sun and getting some clarity out of it. There's Xi Jinping, Premier, next to our President Cyril Ramaphosa. There have been a number of industrial spin-offs. I won't go into all of them. This is just a list over there. But just for example, there's a passive radar system which has been developed using local FM radio broadcasting in order to locate aircraft which we don't want flying over the site. And then to me, the most interesting, so in the last year or so, was the development of 20,000 continuous positive airway pressure ventilators, CPAP ventilators, in response to the COVID-19 pandemic. And to me, the lesson for that was that if you've got a really good balanced team of engineers, you can aim them at almost any engineering problem and get a good outcome. You don't have to recruit in a topic-specific way if you've got that kind of balanced team, particularly with the systems engineers in place. I don't want to go into all of these examples. So, yeah, that's the Center for High Performance Computing, Innovation and Mass Data Storage. This is the SARAO innovation. To show you the impact we're having on young astronomers, this was the 2018 Postgraduate Scholarship Conference, Port Elizabeth, I think. Without the SKA initiative and SARAO, none of these youngsters would have been there, and in fact have been in radio astronomy, or at least a very small fraction of them. Thank you very much, Oleg, Ruby, Russ, all of you, for listening. And over to Petri now, I guess.
Yes, good morning from me as well. And as Oleg was saying, thank you for having a hybrid conference. It is amazing to see actually 3D people in a meeting after such a long time. So thanks for the organizers. Thanks for inviting me for this welcome. So I'm really welcoming you from SAAO perspective, and having an opportunity to say a few words of what we do as SAAO. So do we have the slides on? Oh, there you go. Okay, so just a little overview of what we do, some pretty pictures. And those of you who are not in Cape Town, and just to make you jealous, hey. So this is a pretty picture of Cape Town from where the observatory is. So right in the foreground here, this is the old historic SAAO observatory, or what used to be the Royal Observatory, and the hotel where we're now sitting, those of us here in physical presence, somewhere over there. And yeah, I'm really hoping that those of you visiting Cape Town get to see around. And Our observatory is the older one in this context. It was actually founded 200 years ago. We celebrated our bicentennial last year, October, about this time. 1820, it was already established, although we've been the SAAO for about 50 years now as a South African national observatory. As Rob was saying, we are also a national facility of the NRF, National Research Foundation, so we're sister organizations with SARAO. This is a picture from our headquarters there, a few kilometers away. And it's full of historic telescopes, that side as well. There's a picture of the McLean telescope against the Table Mountain in the background there. And yeah, again, it's a fascinating place for history. This telescope, amongst many other things, it actually, oxygen was discovered in stars with this telescope. I forget the year exactly. I think Christian, sitting in the audience, probably would know. But there's a lot of history there. But then the modern astronomy that we do is the core is in Sutherland. So essentially the optical infrared astronomy on this whole continent, by far the biggest concentration is within our observatory, but the telescopes since 50 years have been growing up on the Sutherland Observing Plateau about 400 kilometers away, obviously because of light pollution, right? And just to put that into context, for those of you who are not familiar, so we're here in Cape Town, Sutherland is there, and we were just seeing pictures that Rob was showing of the Meerkat, which is then further up in the northern Karoo. And the reason why the optical telescopes are in Sutherland, you can see from the satellite picture, it really is a dark site. It is one of we have measurements now for many years of baseline. It's just as dark as the Atacama places, Paranal, essentially as dark as it gets anywhere on the planet for optical astronomy. And it's protected by legislation as well in South Africa, which is absolutely great. The same thing as the radio quietness protection over the radio facilities. And about 40 of our 140 staff are stationed in Sutherland. And let's see. Yeah, so SALT, Southern African Large Telescope, is the largest of the facilities there. It's an international collaboration, but South Africa is the largest partner. We have partners from US, UK, Poland, India. It's been, first light was about 15, 16 years ago, something like that. I forget now exactly, or 17 even. Yeah, in fact, one of the people in the audience over here, David Buckley, he was oversaw the whole building and science operation of it at that time. And yeah, we're in the 10th year of full science operations now, 10th or 11th year right at this moment. It's fully service mode operated, which means massive software needs. Requirements for data delivery, data acquisition, data delivery, proposal management, all of that. And this was the first such big software attempt in coming up with a system for a large telescope in South Africa. And it's working very well at the moment. And hoping that you're hearing more of that kind of things during the week. Let me there's absolutely no time to go into science what SALT and SAAO as a whole do, but I just flash one slide on the kind of the bigger topics that we do, because in addition to being a facility which provides these telescopes for the community, both South Africa and internationally, SAAO, we're also a research institute ourselves, so we do research, we do student supervision, PhD students, master's students, and by and large, I would put our areas into transient science, galaxy evolution, which really leverages the very dark conditions of the southern sky. We're getting into exoplanet science and then computational astrophysics. And it's really that first part, transients, which gets to something that I want to say in a moment. Okay, we do multi-wavelength astronomy. We've done already simultaneous observations with Meerkat, for example, the SAAO telescopes, and SALT. There's one telescope in particular in Sutherland called Meerlicht, which which looks at which shadows fully wherever Meerkat is pointing, this telescope is looking at in the optical, which is the first on the planet. Well, not in the daytime, right? So, radio astronomers have the advantage of looking at the sky in the daytime, so we do it in the nighttime. But wherever Meerkat is pointing at the nighttime, Meerlicht is looking at. So getting fully continuous coverage in multi-wavelength aspects. And not only radio and optical, but others, of course, as well. I should mention just briefly that the birth of multi-messenger astronomy, that epic event a few years ago when the first electromagnetic counterpart of a gravitational wave was discovered, 2017. Our observatory was right in the thick of it, with multiple telescopes on the site involved in that search. And what we're very proud of was that the SALT spectrum was actually the first proper spectrum of that event. This is from that paper with 4,000 odd authors. So the very first timed spectrum was actually from SALT. Okay, and then finally, of our kind of mandate, what SAAO does, we do technology development as well. We have, Rob mentioned this National Ventilator project, for example, a kind of an offshoot, spin-off of what we do with our skills. And it was actually our workshop then who produced with the high precision mechanics capabilities of our workshops, the prototypes of those oxygen blenders. But yeah, software, optics, electronics, control systems, a big part of our organization is doing that. And one of our visions is to start building instruments for other observatories or missions during this decade, not only for us, which we do already. And a big part of what we do in the future is addressing the future of astronomy, which is, for example, the Rubin Observatory LSST surveys, massive data amounts, deluge, and not only the quantity of it, but the speed, the pace of how data come. And that's why we have this concept that we're building, have been thinking of for a couple of years now, called the Intelligent Observatory, where this capability that we have in Sutherland of having multiple telescopes, there's 20 odd now, some of our own, but many hosted, but then South Africa has slices of the time, different kinds of instruments, making that work in the one holistic network, intelligently connected, so that when you do follow-up or when you do surveys, you don't do it individually and with human reaction timescales, but autonomously, automatically. Something happens on the sky, there's a data trigger, broker intelligently selects what should be observed, which instrument should be used, which kind of telescope, which size of telescope, all that happens in a split second, and then the commands go. So that's what we're building. And there's a very specific roadmap for it, involving things like remotely operable telescopes, service mode robotic capabilities, and I won't go into details of this because there's going to be a talk about this in a couple of days' time. But one of the big successes of big successes of the last 2 years during COVID time is that we converted once and for all the Sutherland telescopes that we own and operate into remotely operable ones. They've been operated from Cape Town by the SALT Ops team. There's some new developments on robotic capabilities on the old ancient telescopes as well. Oh, I should mention that some of these telescopes really are old, 80-year-old technology, 50-year-old technology, and you retrofit them to be first remotely operable and then robotic capabilities. And that's actually awesome. It's sometimes harder to do that way rather than building it initially. But I just point you to Steve Potter's talk on Wednesday morning for the Intelligent Observatory talk, because this is at the core of our vision, what we want to do. And I'll finish there. And I really wish you a very productive and great time in this conference and in Cape Town, those of you visiting. Thanks.